Here we are. Let's start with the script editor. First, I will build a little communication script to communicate with a card. Let's start with a power on, power off at the end, and between we will add some ISO type A command that will be sent by the CTS3 to the card. Wake up, anti-collision, request answer to select. Then, let's go to the DAC command on the left-hand side of the script editor and start to set or configure the acquisition card. First, we'll indicate which channel will be used. In my case, I will use the channel 1 with the SMA connector, with an input impedance of 50 ohm, a vertical range of 10 volts to capture the signal, and I will also indicate that the connector which is not used on the channel 1 will be terminate with 50 ohms as well. I will also indicate that the channel 2 will not be used and disable it. Then we'll add the information about the time base, basically the duration of the acquisition that will be performed by the acquisition card. Let's start with 400 microseconds. Then we will need to indicate to the acquisition card when the capture will start. To do so, we can use here the set trigger feature or command available in the script editor. In my case, I would like the DAC to start the capture on a specific event that will be defined with another set trigger command here, indicating that we will use the trigger DAC and the event will be takes on. It's also possible to add a little bit of delay here, negative or positive one, to delay the start of the acquisition. Especially here, I will add a little bit of delay as well, a negative one, to start the capture 40 microseconds before the event. Then we'll indicate that we will start the acquisition. I will also indicate that I want to do a single acquisition. The capture will be downloaded on the system I am using, my computer, my laptop. I would like to display the signal. The DAC file or MPDAC file format or file will be stored on my computer at this location, and I can select where I would like to store the data, and I will continue to overwrite file. Note that if you do not enable this option, new file will be automatically generated and indexed. At the end of the sequence, I will indicate that we will get the acquisition. And finally, I will reposition the power on after or just before the wake up command. With this, if we execute the script, we already we display on the right hand side here the execution log of the communication, but at the same time, since we enable this option, we display directly the result of the acquisition in MP waveform viewer. As you can see, we have access here to the type A modulation for the command generated by the NFC board. We also have access directly to the LMA, the load modulation of the card answer. Let's go a little bit further. Let's say that we would like to complete or go further than this simple script, perform a full transaction or a bigger transaction with a card. quite similar to what could happen in EMVCO communication. So from here, I will add additional command, especially a wake up command. After the wake up command, I will send a HAL command. The card will stay mute. Then I will send a type B wake up command. The card will not answer because I'm using a type A card, so we will have an error timeout that I will ignore by indicating here the error code for the timeout. Then we will send again a wake up command of type A, followed by the anti-collision, the request answer to select. From here we can also start sending some EMVCO command. Now the idea is to capture the full communication. Previously we perform an acquisition of 400 microseconds. It will not be sufficient in order to display the full communication. So let's increase the number of points and perform an acquisition of 400 milliseconds, for example. With this, I can execute the script again. The communication happens, and then the signal or the analog capture made by the acquisition card will be displayed in MP waveform viewer. Let's wait a little. Here we are. I program an acquisition of 400 milliseconds, which is too much regarding the communication I performed. But as you can see, we have access again at the beginning to the wake up A command, followed by the ATQ answer from the card. Then we send the HAL command, the wake up B command, and we start again with a wake up A here, followed by the anti-collision command, the request answer to select, and the select PPSC and select AID command to communicate with the card. Note that it's of course possible to display and use some cursor directly on the burst measurement to perform manual measurement of the signal.